All right, guys, so that was f prime of x. If you want to find the original, you have to essentially think backwards. So let's find the derivative of this first. I think f double prime is easier to find. So the derivative of this, wherever this graph has a maximum or a minimum, what does that mean is happening on the derivative of this graph?
There's a x-intercept.
There's an x-intercept.
What do you call the one with the two?
Double prime.
Double.
Second derivative. Prime prime. Sure.
You're stupid.
Be nice.
You get it right. Be nice.
So, this piece of the graph right here, what kind of slope does it have? Positive. So where will my green graph be? Above the x-axis. So it will actually have a negative slope, but slope. It's gonna be a long day.
Happy Monday.
Yeah. But it's going to be above the x-axis. So I know this section of the second derivative looks like this. Then between this maximum and this minimum, what kind of slope is that? Negative. So where will my green graph be? Below the x-axis. So it's going to do something like that. And then what kind of slope does this have? Positive, so where will the green graph be? Up, yes, above. So that's your second derivative. Close enough. Yeah, I mean, it's more about the shape of it than where these things actually are. And guys, hopefully it makes sense. The f prime of x. That looked like a third degree function to me, right? So it makes sense that the derivative of that would be a second degree or quadratic function. So what do you think the original function is going to be? What degree? Fourth. Okay, so we can piece that together. So wherever the red function here, the first degree, where it has a 0, my original function, just f of x, has either a maximum or a minimum. What do you think it has at that first dot on the left end? Do you think that's a maximum or a minimum? A minimum, yes, because the red graph is below the x-axis, meaning we have negative slope happening, okay? I don't really know where it is, so I'm just going to say it's down here somewhere. I know I have a minimum. What do you think I have where that second blue dot is? A maximum, okay? So we'll draw something like that. Again, the shape, like the location, the height of it, it doesn't have to be perfect here at all. All right, then the next section is below the x-axis, so I know my slope is going to decrease again. So what do I have at that next point? A minimum. Okay. And then what kind of slope do I have to the end? Positive. And does that look like a fourth degree function, kind of? Kind of? Yeah, it crosses the x-axis 4 times, right? So there is your f of x. You can certainly look at the green graph to figure out the concavity of the blue graph, but because we started with the first derivative, it's kind of already there. Questions? We're going to keep practicing those because I know it's hard. Next class, when we do trig derivatives, it's all going to be these sort of ideas of what happens with the first and second derivative graphs. Questions before we start the notes? Are we ready? And if you guys were gone last time and haven't gotten caught up yet, please make sure you watch the video. You can do today even if you haven't watched the video yet, okay?
I mean, I think I read quite a bit out of the book.
The warm-up is really like...
Amazing.
Is that really all you did?
Pretty much.
Okay.
We do we went through the number line test with it too, but it's the same as the first number line test. It's just telling you concavity instead of increasing or decreasing.
I believe you. I think I did it.
Whoa.
Oh.
Weird. I know, that's not what I have clicked on. It's got like a delay happening with my pen. That's never a good sign. You see this, right? Definitely. All right, guys, we are doing implicit differentiation today. This is your second to last notes for the year, guys.
Wait, no. What? I'm so excited. Wait, what is the cumulative?
Which one?
Dude, don't act like you're sad. I'm barely hanging.
So,
not the final.
Okay. On June 1st. So we do this. We do 12-2 today, 12-3 Wednesday, review Friday. Next week, Tuesday, assess on 11-12. Then I'm giving you, I think, 2 review days on the part 3 cumulative. Assess. Review, assess.
And then what's the cumulative?
The last one, I think it's June 9th.
I read the last one. It was just like if you wanted to.
The very last one, yeah. I want you guys to all take it though, just to show you what you know going into calculus.
But like, it's just gonna improve it.
It can only help you. Yeah.
So basically, I'm gonna study my binary.
Yes. It can replace anything.
So basically, I'm gonna try and get a perfect score until I find out in the last grade. That's what I'm hoping for. That's what I can only hope. There's also multiple scores.
Yeah, it's almost.
Algebra review unit.
Okay. Yep. All right, guys. We're gonna look at derivatives a couple ways here. If I asked you to find dy dx here, what would you tell me? 2x. Okay, this is not a trick question, guys. It's an easy derivative, right? Okay. Implicit, we're going to deal with there being more y's involved in our equation. So let me just show you what we're actually doing when we do this dy dx, even though we don't write it. So if I ask you for dy dx, that's the derivative of y with respect to x. You're really doing 2x and then times dx. But we don't write that because it's essentially 1. There's a little more involved with it than that, but you don't have to write that since that's the derivative of x with respect to x, but that's technically what you've been doing. So what it's going to look like today, let me just write one so you can see it, and then I'll talk more about what's up here. Just with my pens today. So we'll be finding dy dx today. But you'll have equations like y cubed if I can read my own writing here, equals x squared plus 5x. You guys see how that's different than what we've been doing? We certainly haven't had a y cubed in anything, okay? We'll get to some that have like y squared equals 3xy plus 2y to the fifth. Like there's just a lot more y's happening. It's not just a single y equals everything. So what you have to do is continue to take the derivative of y with respect to x. And it's just more involved with this. But that's what we're doing. You just don't have to write the dx. So let's go through the first one. I think you'll understand it better if you see one. I'll show you. So looking at just the term y cubed, if you were going to do just the power rule, what would you tell me the derivative of y cubed is? Okay, 3y squared. See, you're good at that. The part that is different that we don't ever write with the x is that we're going to have to write times dy dx because we took the derivative of y with respect to x. Okay? So just know that every time you do the derivative of any y term, you're going to have this dy dx. And then on the right side, what's the derivative of x squared? And the derivative of 5x. Okay. So what am I actually trying to find? Yeah, what were the directions? Find dy dx. So I have to solve this for dy dx. I need that to be alone on one side. So what is dy dx going to equal? Yeah. And that is implicit differentiation. Okay. It's not that, right? It's not that terrible.
Oh, like we're just done?
You're done.
Now, because it's off the rails.
Well,
You guys are adding more Y's. Like, what?
what'd you say, Will? So, all the stuff we've done before is just very basic functions, right? A nice singular Y equals. The world of calculus is not all just happy little Y. So we have to be able to work with these functions, or not functions, with these expressions that are Y cubed, Y's times X's, like all of that. Like think of the conic section stuff. We should be able to take this. So that's why. All right, let's try another one, guys. Okay, let's do y cubed. So same directions here. I'm not going to write it every time. Minus 2y plus x cubed. No, this is not going on. Equals x squared plus 2. So anytime you take the derivative of a y.
Anytime?
Anytime. So you're going to have to put it in twice.
Okay.
Yes. Do you guys want to try it? Okay. Ready, go. You can certainly move the x over first if you want. If not, you're going to move it over later.
Certainly.
Certainly.
It's so certain.
It is.
You get 2y.
dy dx is, yes. So, how do you solve for that, though?
Do the thing.
The thing. Mhm.
Yeah.
Thing where you
There's a key thing.
With the other thing.
Yep.
Then you get like the other thing that's solved for sure.
Sounds about right.
I got it already.
And we haven't said it yet. Is this your unit?
This is not.
I understood that and I was thinking that.
Oh wait, it paused.
I'm gonna pretend like I know what I'm doing.
Oh my god.
That's a good approach.
Like, is there like a, and I'm allowed to root it, or no, it's just gonna be here.
No need to root, because you're solving for dy dx. There is factoring, guys.
What do you mean there's factoring?
I mean, there's factoring.
There's never
You guys look shocked, like factoring. Why would factoring ever show up? We factor pretty much every day, guys. Yes, Jane.
Sure.
That's just a GCF. Yeah, it's not like factoring a trinomial. No. But pulling out a GCF is a factoring. It's like baby factoring. Step 1 factoring.
Oh, I get it.
Yes.
See, when I hear factoring, I think like you have to do the whole like X thing, you know what I mean? Like,
It's just the derivative of y with respect to x. Like it's, yeah. But all we had there was just y. So you took the derivative of y in v1 times dy dx. So yeah. Yeah, this is
Oh my god, I feel so
Uh-huh.
stupid. Okay. That's probably. Oh yeah, go.
Are we ready,
Really
guys?
funny sort of book, so. There's so much trauma that happened that event. Oh my god. Literally so much tea. I'll start skipping. Nothing bad. It was just like, oh.
No, I just love tea.
No, one of the bad ones.
Hockey hotties. Hockey.
I don't know what any of the books are about, by the way. I figured it out. I literally was like,
Okay, guys.
like a teenage book that I
Can I do I won't do it all in one step. I don't want to lose anyone.
Wait, these are so crisp.
No. So much tea.
Are we okay,
Like I
guys?
said, you get like the thing,
And then you do the thing.
and then you do the other thing. If you taught like that, I don't know if I
I
could.
scored a hat trick in my next game.
I feel like I'd be
Oh.
pretty bad. You might be like failing every year, so it's worth it.
All right, guys, for dy dx, did you get negative 3x squared plus 2x all over 3y squared minus 2? Okay. Yeah. I started with the last step first.
Girl was walking alone in the garage.
Did you skip the middle step?
All of a sudden there's like this like
Yes.
That's fine.
Like right for the DYDX
guy comes out and tries.
Like
Yeah, I almost skipped this step, but I didn't want to lose anybody. Did you do this step?
like a DYDX individually. I just put it outside.
It's okay as long as you're seeing it. Be careful when we get into like product rule with implicit, that sort of stuff. Like just don't skip things and lose things.
Yeah.
You still got here, right?
Yeah. Because
Yeah.
DYDX like the point of it just for every like Y value.
You got your X.
Because you've technically been doing this all along. Like if you had y equals 3x squared. Well, the derivative of y is 1
Oh, I forgot to
times dy dx,
Yeah.
right? So like you've been doing it, but just because it was y to the first power, didn't even realize you were doing it. Okay, let's try again. Now you're getting the basics, right? You've got the general idea.
I don't even know what
Why are you slow?
No.
Okay, slope of the tangent line. What does that mean? Derivative. That should just in your brain be like derivative, derivative, derivative. Let's see. My paper did not copy well. Root 2, comma, negative 1 over root 2. For this lovely equation of x squared plus 4y squared equals 4. Okay. Yeah.
Can I take my this is my unit back?
They're recorded. It's there. I mean,
All the evidence.
there's no takebacks. I'm recording. Yeah. So guys, if I'm asking for just the slope, like what kind of answer should I get at the end?
You know, numbers.
A number. Yes, I should get like a number at the end, okay?
Like a number.
Like a number. Did we get a number?
No, we're doing great. We're doing great.
Okay.
I think I'm really oversimplifying
And then
this.
you're gonna plug in the point to the neg, so then it becomes the root 2. Why does this have to be so weird? Okay, and then what is this?
Yeah, it's just like a lot of weird simplifying.
I don't like it.
Okay.
don't think that's correct.
No, it doesn't make sense. I don't think it means 0 equals 4. Alright.
It doesn't exist.
What on earth is happening?
Wait, no, I think
Have we
we
had
can
the flyer yet?
No.
So it might be today.
Let's see. It's on my calendar. I can tell you when. Hold on.
No, it's positive one.
Wait, what's it positive? Oh, yeah, that makes sense.
Because it's negative.
I'm gonna pretend that's how it works.
Positive one.
That's something not.
A week from Wednesday,
Because I got.
A week from Wednesday.
May 24th. And it's at 1:30. It's at 1:30. So that's
That'll be
during 7th.
There's no way that's right.
How many creamers do you have, by the way? Like, how is that?
Yes. Good job. I know, like the derivative part is actually easy, and then you're like, oh, so many square roots. All right, guys, let's go through it.
Yes, please.
What do we get for an answer?
Something not correct. Not looking right.
How many of you got 1/2?
No.
It was 1/2. All right, let's go through the derivative. So how do I take the derivative of x squared plus 4y squared equals 4? 2x. Okay. Equals 0, right? Okay, I'm solving for dy dx.
It's 2x, it's 2x.
Thanks. Happy Monday again, everyone.
I know. It's always on Mondays I get
What happens to the 4?
And then like.
Well, what's the
other
derivative of
days,
4?
That's just.
No, it's not O, it's 0.
Is it not necessary to like bring the y to the other side? Like it doesn't really matter.
It doesn't matter.
So you could just start it off with that. Okay.
That's why I did, yes. You can move it first if you want, but you don't have to. Okay, so I've got dy dx. I'm going to simplify it just slightly. Are we okay with negative x over 4y? Yes?
Yeah.
Okay. But now what? Because I've asked for the slope. I plug this in. I'm going to just go over here because it's a silly amount of simplifying. 1 over root 2. That's pretty, right? The negatives are obviously going to cancel.
Wait, I got that.
Okay. And then this is divided by 4 over root 2, correct? Okay. That is root 2 times root 2 over 4, yes? Okay, what's root 2 times root 2? 2. So 1/2 is your slope. Nate?
That's crazy.
It's gonna be a really fun test.
Because we're taking the derivative of y with respect to x. So anytime, again, you've been doing this all along, you just didn't know you were doing it. Like in math space, you had maybe like y equals 5x squared plus 2x, right? And your answer was dy dx equals, because if I took the derivative of y right here, wouldn't it be just 1 times dy dx? So you've done it the whole time.
Okay.
And then this side was just,
There's also you can
well, because now we are, everything you've done to this point has been y to the first power, and that is it. Which the derivative of all of those are just 1 times dy dx. But now I've got like y cubed equals that. So I got it. The derivative now is not just 1, it's 3y squared, still times dy dx. Okay? It's because the y got more complicated that we have to do more. All right? Because in calculus, it's not all just going to be like happy y equals something, right? Like this last one, what is that, a circle? You know, you've got, not a circle, ellipse. Anyway, conic sections, things that are not just happy linear or polynomial type functions. Okay. So that's why we get to do more now. All right, let's try again. Oh, do you need me to go back? Okay.
Yeah, no, and then the guys got away. And then the police were called, of course. Yeah, there's at the event I was working, a woman was abducted. She was walking alone in a parking lot.
That's terrifying.
It's crazy, dude. And so then the author, like the main author, the multi-millionaire author, like saw her personally and was, I'm so sorry this happened to you. She was like,
Ow.
Turns out one girl passed out at the event, and then she got like her stuff personally signed, and she almost passed out again. People are crazy.
People are crazy. Yeah. They like hyperventilate.
Look on that. They really could, honestly.
Maddie, you good? Okay. All right, guys. 2 examples left, okay?
Oh my god.
I know.
Whoa.
Only 2. Don't get scared when I write this one, okay?
How do you mean don't be scared? Whoa, whoa,
Okay, and yes, it looks like I've lost my mind and just started throwing 2s everywhere, but that's actually how you write it, okay?
Yes.
I promise.
It looks like I lost my mind.
Because you have.
I have not. I know it looks like it.
I do not know what I am doing.
Just making it up.
It's no fun, dude.
Okay, that is I know it looks bizarre, guys. It's the second derivative of y with respect to x. Like, this is second derivative notation. I know the 2's look like they're not in the right spot here. Like, y is 1 by the d, y is 1 by the x. That is the notation for second derivative. The second derivative of y with respect to x, okay?
Sure.
I know it's weird. Just trust it right now.
We're trusting the process.
This one will take us a bit. Okay. Are we ready? The second derivative is just the derivative of the first derivative. So you're going to go through the whole process, and then you'll see what happens when we do this. It just let us get through the first derivative, and then you'll see.
Yeah, but like,
You can keep going. I don't think so. That's a good question. But algebraically, you can find the 17th derivative. A lot of them are going to be 0. Oh my gosh, can you imagine me trying to be like, okay, they made a mistake up here. Follow through error. That would be a nightmare. All right, guys, this is negative x times y. What do you think we have to use here? What? What'd you say? No. Okay. Sorry. I don't know what I thought you said, but I was like, no, not divided. What do we use with derivatives when things are multiplied together? The product rule. So remember how I said all that stuff from 11? You got to use the 12? I wasn't kidding. Okay, product rule. We'll write it again because you don't have to write this again. I'm just going to remind you because some of you wrote it incorrectly on your last test. We're all excited that you had the product rule and you wrote the wrong product rule.
Oh my gosh. I remember like the sine cosine.
Yeah, that's fine. I just go in this order because it's the same order as the quotient rule. So then I have less to remember.
It was the back.
Oh, this is the weird thing.
Yeah. You guys did this on the back on that table one?
Yeah, okay.
Yeah.
Oh, we did?
Well, some of you did.
No, I certainly did not do that.
uncomfortable.
Plus.
I was happily staring at that. Like, no.
Hey guys, the order really doesn't matter. I go in this order because this is the same as the quotient rule, but you just need to take one function times the derivative of the other function plus vice versa. Okay? All right, so let's look at it. So I'm going to take y times the derivative of negative x. So what's the derivative of negative x? Negative 1. Plus negative x times what's the derivative of y? Yeah. You can put the 1 if you want, if that makes you feel better. Yeah. Okay.
Whoa.
Maddie. You were very close to saying something. All right, what's the derivative of x? 1. Yeah, there's the other side to the equation.
Wait,
Minus.
So then you just toss it as dy over dx?
Did we take the derivative of y?
Absolutely.
Then yes, you toss it in.
You just toss it.
Just wait, did I get enough? Let me write another one.
Right,
It's only when you take derivative of y. So 1 minus what? Yeah, you can write the 1 if you want. dy dx. Okay. Yay. What do you think we're solving for? Oh, yes. So I'm going to write negative x dy dx, and then I'm going to bring over plus dy dx. And on the other side, I will have 1 plus y. I just moved things. Okay? I mean, I got rid of some parentheses as well.
What?
What?
Okay, hold on. So, negative x times dy over dx. Okay, see that?
Yes.
Now, you get negative 1. Add the dy over dx, and then you subtract by
What's left in parentheses when I factor it out? Negative x plus 1. Okay.
Oh, let's do that. That's cool.
All right.
dy over dx. Doing thing, and there's negative x plus 1.
I was going to say, if only I had just asked for the first derivative, we'd be done.
What?
What are you?
But I did it.
Did we do that whole thing?
The quotient rule now.
Okay.
Okay. Are we okay to this point?
Yeah.
Simon, you look like maybe you've been injured. I don't know.
Simon's good.
Here it's fine, right?
Out of everybody here, Simon is the one who took having.
Simon's okay. All right. He had a pained look.
And then
Okay. So, second derivative, guys.
Oh, great. Yeah. Here we go.
This is what we're finding.
So all the times where we put this, their squares in the wrong places, will you be mad?
I'd be mad.
Will that get?
I don't know if I'll be mad, but I might knock some points off here and there.
Joyous.
Okay, quotient rule. Denominator, so negative x plus 1
di, so it's
times, okay, what is the derivative of that numerator?
minus I.
1, right?
1i.
With a,
With the
dy
thing.
dx.
okay, can I just write dy dx, guys? Are we okay with not writing the 1? Okay.
No, it's really important.
If you want the 1, you write the 1. Minus numerator, so 1 plus y, times derivative of the denominator. So what's the derivative of your denominator?
Negative dy.
No.
No.
Negative
It's not y. I'm trying to get my breath.
negative 1. Okay. All over what? Okay, so negative x plus 1 quantity squared. I can't.
This is so long.
Okay.
Oh, so like
So we have a dy dx in the middle of this that we need to simplify. But do I know what dy dx equals?
yeah.
Yeah, didn't I find that already?
No.
I did. I promise I did.
No, you didn't.
No.
No, you did not.
You guys turn into like toddlers. No.
No.
I don't want to do it.
Yeah, so just 1 plus 5, right?
It works out pretty well, right? Because we get
No,
negative x plus
speak
1.
for yourself.
want to play this.
What it feels
I
like.
want to wake up.
And then guys, I'm going to go ahead and distribute here. Do you see how the negative times the negative will just make this plus 1
Sure.
plus y?
Definitely.
Okay.
Wait.
It gets much better after this step. We're almost there.
This is almost there.
Okay, Ben, you can't just stop in the middle. What's up?
Is it possible to open up the messages because it said it was like closed or something?
Yeah, because it was due already. So I'll open the second one here in a little bit. But, yeah. What happens in that first fraction? Do you see the canceling that's going to happen? Okay. So I have 1 plus y plus 1 plus y. So what do I really have?
2 plus 2.
Okay, and we're done.
Oh.
What?
Yeah. So I've got 2 plus 2y over this thing
Right.
squared, and you are done. So it gets real ugly, and then it's fine. Okay.
I think I'm good for the time.
Quizzes.
One more example. That was only number 4.
That example took my whole page.
Yeah, it's a big one.
I'm so excited to look back on these notes. Like, what?
What is happening?
Look back at this. It's like really pessimistic.
Okay, good.
No, I love it. It makes me so happy by people like that.
All right, guys, last one. Slope of the tangent line at the point 2, 1. Or I can't read what I wrote. X, Y plus 2x
We love it.
y cubed equals
Oh,
6.
oh, we love that.
We
Yay.
love that. Do we see product rule? Twice. Yes. All right.
Oh, no.
I didn't even see.
That's too many terms. I'm saying that here.
And again, you should get just a number at the end. You're finding the
Oh, we're doing
slope.
this ourselves. Okay.
Yep. Ready, go. No time for crying. You can do it.
I'm really about to cry, like, for real.
That's time for crying.
I can't do this anymore, man.
Yes, you can. I know. This is a lot on a Monday.
What does our selection really get? Is it multiplying in the parentheses or addition in the parentheses? It's like when you.
Who thought this was a good idea?
It's this times G. Here, I'll go here again.
This way. Oh, slide. Okay.
Yeah.
Yeah, I found this. Yeah.
I'm gonna say his last name was Calculus.
Like, did this fake map?
Not
Yeah.
I think offering and they both had a lot of stupid hair. They converted I am a calculus.
Who thought this was a good idea?
And they were,
I want to be
and the subtitle of calculus is discoverer or inventor. I'm not exactly sure if I Okay, so he was buried in the Westminster Abbey.
It was very good.
So the other one.
This is right. Yeah, that's
is
right.
in I can't.
Yes.
No, let me do.
I'm sorry.
It's okay.
What is this?
Wait, what is this?
This is too many valid answers.
Apparently the guy who invented Ecos was a diplomat.
Of course he was.
Well, one was Isaac Newton, the other one was Gottfried Wilhelm.
Wilhelm.
Someone did, like, two students recently did. They like added on.
Yeah, like in Georgia or something? Yeah.
I know, but they're set for life.
Yo, Simon just got so high. He's like, oh my god!
What is
Sorry for the random share.
Y times 1, right? And then plus.
It's when you do the derivative of y.
Where's that?
The first imaginary number to the second. This is fake. Times
If they're not real,
over
Oh my god.
This is just another one of those moments.
this is just fake. Some random guy just made this up.
Like I've kind of been slow sailing since like the 7th grade. We hit algebra and I'm still.
This is definitely the wrong number.
2 times.
This is
Anybody want to yell out their answer for slope?
We're not done yet.
Okay. What'd you say? No.
I got a negative 4.
Oh wait, I forgot. Oh yeah, I forgot.
That's right.
I think.
No way.
Wait. Are you sure? Wait. No, come here. You mixed two numbers around. Come here. It's this. Is that? Did you get 4 over 14? 3 over 14? Because I'm like, yeah, you're right, but.
I got negative 4 over 13.
Y over x plus.
I'm looking for a number.
I got negative 4 over 13.
Oh, that's bizarre. Bring it up here. Let me see what you did.
Set, bro, set.
It's probably a coincidence. It's up there.
Okay.
It's probably a coincidence.
Thank you. Ooh, I have minus y up here, and you have minus x.
I got a number. That's all.
What did I do?
I don't know. Let's
They're not the
see.
correct numbers.
Okay. This should be a y. Not an x. Y.
Oh yeah.
So that 1x, and then that.
Alright.
Okay.
Yeah, I got a negative 3 over 7.
You're kind of close.
What do you mean kind of close? I think our best one is very
No, the negative 3 is the numerator.
Is it 3 quarters line?
Yay!
How did you guys? Lisa, like, can you tell me if I'm on the right track?
Did I veer off anywhere else?
I just don't want to keep on going until.
What is what's this? Where'd that come from?
It was the.
Oh, you just combined, but that wouldn't be. So when you, okay, this is what's wrong. Because when you do the derivative of y, it is 1. What else?
Oh, the yes. So if I add so it should be y plus x dy
I don't have to
dx.
change too much though.
Yes, and then
It doesn't make any sense, bro.
plus. I don't know why that's.
This should be a plus.
Yeah. This isn't that this next term.
Yes.
Okay. And so that's fine, and then it'd be 2x, 3y squared. What else needs to go with that? 'Cause you took the
The
derivative.
dy dx.
Yeah. Oh, okay. Why did you do this?
Because I forgot to add the dy dx.
Okay, so it's still 3y squared.
Oh, I
And
just
then 2y.
okay.
Okay.
No, so now I'm here.
Don't lose them.
Yeah.
I've lost something and I don't know where.
Negative.
But I thought I lost it.
So x divided dx.
Oh, I got that part right.
Off to a good start.
Plus 6xy 0.
There's your first step, guys.
Oh.
This is the last exam, right?
This is the last exam.
That's. I messed up.
This. Got dy dx.
Yes.
That's the scale.
I messed up the key.
No.
Derivative of 6 is 0.
Oh.
Wow.
Okay. Sure.
Why am I the format?
Oh, I need to plug it out.
That's the derivative, guys. Then you plug in the 2 and the 1.
I told you, oh my god, I told you that you shouldn't have kept the 6.
Yes. Well, dy dx equals that, and then you're finding the slope. So the slope is -3/14. You made it through notes, guys.
Okay, let's go to sleep. It's nap time.
Quizzes time, guys.
What?
Quizzes.
See, I'm just gonna spectate quizzes.
No, this is a good one. You get to be a little guy climbing a mountain today.
Oh my goodness. I am so excited to go to college. Right. As
Oh.
fun as that sounds, I am okay.
Sorry. Let me stop the video too.